Good morning, students. Today I am going to discuss our new topic, angular velocity and acceleration of the connecting rod. I already discussed in previous lecture analytical method for calculating velocity and acceleration of the piston in a slider crank chain mechanism. I hope all of you understand this topic by the help of my previous video. Okay, now we're going to start this topic. The systematic diagram is same for this topic as previous. I can show you again the systematic diagram for this. This is a simple slider crank chain mechanism in which OC represents the crank and PC represents a connecting rod and PO denotes a line of stroke. C dash point C dash represents inner dead center. C double dash represents outer dead center. Our crank is inclined at an angle theta, that is called crank angle, and our connecting rod is inclined with line of stroke with an angle phi. We already know that this mechanism is used. Which mechanism? Slider crank chain mechanism. Slider crank chain mechanism is used for converting rotary motion into reciprocating motion. Rotary motion into reciprocating motion or vice versa. We already discussed point P and P dash. Point P shows the velocity of the piston. P dash, P to P dash represent the displacement. Now we discuss, let us consider the motion of a crank and connecting rod. OCB the crank and PC is the connecting rod, and crank rotate with an angular velocity omega radian per second through an angle theta from the inner dead center. We already discussed about this. Now let us suppose a small L length of the connecting rod between the centers are radius of crank pin circle and F inclination of the connecting rod, F phi as it is inclination of the connecting rod to the line of stroke, and small n, it is the ratio between the length of the connecting rod to the radius of the crank. Okay, from the geometry of the figure we find that the value of CQ, I already told you CQ is the common line. CQ is the common line between both the triangle CQO and CQP. We can calculate the value CQ when we consider the triangle CQO, then CQ equals to R sine theta. When we consider CPQ, then the value of CQ is L sine phi. Now, from the geometry we got CQ equals to L sine phi and equals to R sine theta, or we can calculate the ratio L by R sine theta upon sine phi, and we got the value sine phi equals to sine theta by n. I hope all of you understand. Now differentiate this equation sine phi equals to sine theta upon n. When we differentiate sine phi, we got value cos phi into d phi upon dt, and in right side we got sine theta, differentiation of sine theta is cos theta upon n, and multiply by d theta by dt, because we are going to differentiate this equation with respect to time. Okay, and in previous lecture I already told you the value of d theta upon dt equals to omega, angular velocity. Okay, since the angular velocity of the connecting rod PC is the same as the angular velocity of point P with respect to C, and it is equal to d phi over dt. Okay, here we got the value d phi over dt is cos theta upon n multiply omega upon cos phi. You can see you can see this value, and now I'm going to put this value from the previous equation. What is the value of cos phi? We already calculate in last topic, and now I can show you the value of cos phi. This one is the value of cos phi. Now we can get the value of angular velocity of connecting rod omega pc equals to omega upon n multiply cos theta, and when we put the value of cos phi, then we got 1 minus sin square theta upon n square ki whole power 1 by 2, and when we simplify this equation, then we got the value omega upon n multiply by cos theta upon 1 upon n square minus sin square theta ki whole power 1 by 2. So I hope you will understand how we get this value, angular velocity for the connecting rod. Now I want to calculate new value, which is angular acceleration of the connecting rod. We already know that when any body is rotating about its own axis, then we got an angular acceleration, and it is denoted by alpha. Here I want to calculate angular acceleration for the connecting rod, then we called it is alpha in suffix pc, alpha pc. Okay, then what is the value of alpha pc? Value of alpha pc is equals to differentiation of omega pc with respect to time. Differentiation of omega pc with respect to time, where omega pc is the angular velocity of the connecting rod. You can see here कि alpha pc is our angular acceleration of p with respect to c. Then how can we differentiate and how can we calculate the value of this thing? So d over dt omega pc equals to d over d theta omega pc multiplied by d theta over dt. Again d theta over dt, d theta over dt is omega. I can show you, and d omega pc upon d theta equals to minus omega sin theta into n square minus 1 upon n square minus sin square theta की whole power 3 by 2. I hope there is no issue, because this is the basically simply differentiation. You already know about this thing. You already know the what is the division rule in differentiation. For your kind information, I am discussing in the when we are going to differentiate an equation which is in the form of numerator and denominator, then we use this formula: second function differentiation into first function minus first function differentiation into second function upon second function का whole square. Then we got this value d omega pc upon d theta. I hope everybody understand how I calculate this value. Now alpha pc equals to, I already told you, d omega pc upon d theta multiply by d theta over dt, multiply by d theta over dt. Then we put here omega. So finally we got the value of alpha pc equals to minus omega square multiply sine theta in bracket n square minus 1 n square minus n square theta upon 3 by 2, where n is L by R ratio, omega angular velocity of the connecting rod, theta is the crank angle. Okay, there are the two conditions when sin square theta is actually theta is very small angle, very little angle. When we are going its higher value, then it is very negligible value. We got very negligible value. So we neglect sin square theta is small as compared to n square. That means we put value equals to 1. So here we put the value of sin square theta equals to 1. Then we got this equation. Then we got this equation. Omega pc equals to omega cos theta upon n, and alpha pc equals to minus omega square sin theta upon n. Here we can apply again two conditions. When the crank at inner dead center, then we put the value of theta equals to 0. We put the value of theta equals to 0. Then we got angular velocity equals to omega upon n for the connecting rod, and angular velocity, angular acceleration equals to 0 because sine 0 equals to 0 and cos 0 equals to 1. When the crank is located at ODC, outer dead center, then the value of theta equals to 180. We already know that cos 180's value is 1 minus cos 180 equals to minus 1, and sin 180 you already know that, and we can calculate these value omega pc and alpha pc. I hope all of you understand by the helping this video. If you have any issue and doubt, you can mail me or message me on my mail id. Thank you so much.